Okay, so the next question has to do with two separate reactions that have to deal with using elemental bromine. All right, so this particular compound right here was picked on purpose. This is called toluene. You could call it methylbenzene if you wanted to. The reason that this was picked is it's got two different types of carbons. It's got a benzene ring in it, and those have their own types of carbons, and it's also got this methyl group on it, which is an inherently different type of carbon. All right, this is a essentially an alkane type carbon, and these right here are going to be like the types of carbons that you have on a benzene ring, obviously. All right, so first question is, what would the product be if you treat it with bromine in the presence of UV light? All right, so when you see the halogen with the UV light, you should think a radical mechanism. All right, and what type of carbon hydrogens do the bromine or the halogen radicals react with? It's going to be with the alkyl hydrogens. All right, so all you have to do is replace one of the hydrogens with the bromine. By the way, you would have a byproduct of HBr as a byproduct here, but this would be the major product. All right, if the next reaction is using elemental bromine with an aluminum tribromide catalyst, or I guess you could say this is aluminum bromide. And the difference is that this is going to be a substitution reaction that occurs with the hydrogen on the benzene ring. All right, so you could either substitute this hydrogen, or this hydrogen. Any of those would be acceptable. In case you're wondering, why didn't we show substitution over here or over here? And it's because if we substituted at this position right here, it would be the exact same molecule as this one right here. All right, if you take this molecule right here and you flip it over like a pancake, you would see that it would just move the bromine to that side right there. So and the next product, it has to do with oops, this is a little bit out of order, I'm sorry. This has to do with some of the amine problems. This is pyrrolidine, that would be a secondary amine. N-methylpyrrolidine, that's a tertiary amine. All right. This question right here has to do with oxidation. So in the first one, so first of all, this is the starting material of your of the reaction. It says you get two different products. All right. Well, the reason that you could get two different products here is that there's two steps in the oxidation from this point. All right. This is a primary alcohol. So the initial oxidation would yield this aldehyde. All right. But aldehydes can get oxidized up to a carboxylic acid. So if you got two different products, they would probably be these two products. All right. But if we use this as a starting material, you only get one product. And the reason for the difference is that this is a secondary alcohol, and it can get oxidized up to a ketone. All right. But once you're at a ketone, you can't oxidize up from that. All right. So this would be the end of the line in terms of oxidation. All right. So the last question is an NMR question, and it says if we had reacted 1-butene with sulfuric acid, it's going to produce two different products. All right. It says that the major product would have this NMR. All right. So first of all, the two products are going to be this and this right here. All right. So if you took this particular alkene, if you just put the OH on one and the H on the other, and then you reverse that, you would get these two products. All right. So what you want to do is, easiest way to do this is kind of draw it and try to ask yourself, what would the NMR look like? All right. Well, on this one, this hydrogen right here would be a singlet. All hydroxyl hydrogens are going to be singlets, and one hydrogen. This methylene right here, or this CH2, has got two hydrogens on this neighbor. That would make it a triplet with two protons. This is a quintet because it's got 1, 2, 3, 4 neighbors. So that should have a signal with 5 things. All right. This would be a sextet because it's got 1, 2, 3 on that methyl group and 4, 5 there. All right, and this would be a triplet. All right, going through this molecule, hopefully you could do it the same way. This is a, oops, let me see, that would be, okay, this particular carbon right here, there's 2 hydrogens there, and it's got 1 hydrogen that's not drawn right here, so there's a hydrogen there, and then 3 hydrogens on this methyl group, so that makes a total of 4 neighboring hydrogens. That makes that a quintet. This is a triplet. This is a sextet right here. All right, and the reason that's a sextet is that it's got 1, 2, 3 neighbors on that methyl group, 1, 2 there, so that makes that a total of 5 neighbors, which means it's going to have a signal with 6 peaks in it. All right, this is going to be a big doublet because there's only 1 hydrogen right there. And if we just compare all this data to these 2 NMRs, hopefully you can see that this data is consistent with this particular structure. All right, and that would definitely be the major product of this reaction.